All right, let's dive right in. Today, we're going to crack open a fantastic old engineering book to explore the raw, untamed power that basically kick-started the modern age. We're going to look at the violent birth of the steam engine, and then the rise of the internal combustion engine, the one that put all that power into our hands.
So, to really get this, you first have to understand the sheer force we're dealing with. And this quote, well, it says everything. A cubic foot of hot water with the same energy as a pound of gunpowder. We're not talking about a whistling teapot here. We're talking about weapon-grade explosive energy trapped inside a metal box. That's the volatile, incredibly dangerous force that early engineers were trying to tame. So, okay, how do you even begin to wrap your head around an invisible force that powerful? Well, the early engineers had some pretty incredible ways of picturing what was going on inside their boilers. I just love this description. Forget the dry physics for a second, and just imagine that. Millions of tiny water molecules heated up into a furious swarm, acting like angry bees, literally smashing themselves against the inside of their metal hive. It gives you such a perfect visceral feeling for what steam pressure really is, just a relentless, violent bombardment. And with that much violent energy, the #1 priority was just survival. You know, if you boil water in an open pot, the steam just escapes, no big deal. But if you seal it up inside an iron boiler, those angry bees have nowhere to go, and the pressure just builds and builds and builds. So before you could even think about making an engine work, you had to figure out how to keep it from becoming a bomb. And this was the answer: the safety valve. It's so simple, but it's brilliant. It's basically a plug with a weight on it. If the pressure inside gets too strong, it just pushes the plug open, lets off some steam, and the whole thing doesn't blow up. It was the absolute first step in taming the beast. Okay, so the boiler isn't going to explode anymore. That's a good start. But now for the real challenge. How do you take all that chaotic, angry bee energy and actually do something useful with it? How do you turn all that smashing and bashing into controlled motion? Well, that's where the piston comes in. And this right here, this is the beating heart of the early steam engine. The cylinder. You pump steam in, it shoves that piston back and forth, and just like that, pressure becomes power. And the guy who really became the master of this was, of course, James Watt. But his story, it's not some simple eureka moment. It was an absolute struggle. You got to appreciate how incredibly hard this was. I mean, imagine you've just invented a world-changing engine, but you can't use the most obvious part to make it work, the crank, because some rival swooped in and patented it first. So Watt had to invent 5 other, way more complicated ways to do the same job. And the quality of manufacturing back then, it was basically non-existent. He was genuinely thrilled when a cylinder was only 3/8 of an inch out of round. But here's the really cool insight. The idea of the engine was so powerful, it literally forced the entire manufacturing industry to get better and more precise just to keep up. Now, the piston engine was an absolute powerhouse, no doubt. But it had its limits. It was clunky, it vibrated like crazy, and if you wanted more power, you just had to build a bigger one. The next great leap forward meant completely rethinking how to use steam. And this was it, the Parsons steam turbine. Instead of one big piston getting shoved back and forth, the turbine works by blasting steam across thousands of tiny little blades or vanes, spinning a shaft at incredible speeds. Think of it like a pinwheel powered by a hurricane. It was smoother, way more efficient, and could generate power on a scale that the old piston engines couldn't even dream of. And when I say a new scale, I mean it. Just look at this thing. That is not some small engine for a workshop. That's the enormous casing for a turbine going into an ocean liner, the Carmania. See the worker standing next to it? He's totally dwarfed. This was industrial power becoming truly epic. And get this, inside those huge casings for the Carmania, there were 1,115,000 of those little individual blades. Think about that for a second. That marks a huge shift in how things are made. It's not about one craftsman building one big imperfect part anymore. This is about the precision mass production of over 1 million identical pieces that all have to work together perfectly. This was the future of manufacturing, and it was born right here, inside the turbine. So what do you get for all that incredible, precise work? You get speed. Mind-blowing speed. Of course, this new power was immediately snatched up for military use. A turbine-powered destroyer, the HMS Viper, hit a record-breaking 42 miles per hour on the water. That was as fast as an express train at the time. The turbine had just completely changed the game. But while these giant turbines were busy conquering the oceans, a totally new kind of engine was being perfected back on land.
This one was smaller, nimbler, and it was about to bring mechanical power not just to giant ships, but to individual people.
And the crucial difference is right there in the name: internal combustion. See, with a steam engine, you have a big fire outside the engine, boiling water to make steam. With this new engine, the explosion from burning petrol happens right inside the cylinder itself, pushing the piston directly. It's a much more direct, efficient, and compact way to make power.
But this new engine brought a whole new set of challenges. You couldn't just swap out a boiler for a gas tank. You needed completely new systems, like this incredibly complicated gearbox, just to control the engine's power and get it to the wheels. A whole new mechanical language had to be invented. And that created new industries for parts and repairs, and a whole new profession, the mechanic.
And the machine that would carry this new power out into the world was, of course, the automobile. This wasn't just a new way to get around. This was a technology that was about to completely reshape our society, redraw our cities, and redefine our personal lives. Now, you might think the car's big advantage was speed, but this early data shows it was something much more important: control. At just 16 miles per hour, a horse-drawn coach needed 70 feet to make an emergency stop. A car? Less than half that. This superior control and safety was probably way more important than pure speed for getting people on board. It proved this new machine wasn't some reckless toy. It was actually a reliable, responsive tool. But oh, the performance potential was staggering. Even in these super early days, people were building cars that were hitting speeds over 120 miles per hour. And that kind of speed doesn't just get you from A to B faster. It fundamentally shrinks the world around you. A trip that took all day on a horse could now be done in an hour or two. And that completely changed where people could live, where they could work. The idea of the suburb, the road trip, it was all being born right then and there. And this brings us right back around. The authors of this book, writing right at the start of the 20th century, they saw what was coming. They knew that the motor car wasn't just a novelty. They knew it was going to be an engine of social change on the exact same scale as the steam engine had been, and that it was going to change absolutely everything about daily life. From the contained explosion of steam to the controlled explosion of petrol, each new engine just completely redefined what was possible, and it reshaped the world in the process. It really makes you wonder, as we're witnessing the rise of things like AI and new energy sources today, what's going to be the next engine that completely remakes our world?